Alright, carrying on to our first of three examples. This one is about stretches and compressions. Here we're given y is equal to f of x, and it's really defined by 1, 2, 3, 4 points that are joined together. And we're going to sketch these two following graphs. So maybe first what we'll do is convert each of these points to an ordered pair of our x values and our, you can either call it y or f of x. So we have a -3, a -1, a 1, and a 2 for our x values, just looking at those four. And then my y values were, my y values are 2, and then 2 again, and then 0, and then 1. Okay, so a minute ago in the previous page we did y is equal to negative f of x, right? And what did we do there? We multiplied the y values by -1. Not too surprising that what we're going to do here is we're going to multiply the y values by 2. So whatever that value was, right? So in our mapping kind of notation, if x comma y is an ordered pair of our original function, like say -3 comma 2, the corresponding point would be equal to x comma 2y. So whatever number is out in front there of that f of x, we're going to multiply our y values by that. So we get x, and then over here we'll write, I can put a bit more space into this, 2, y is equal to 2 f of x. So -3, -1, 1, and 2. And now I doubled each of those other numbers, so I get 4, 4, 0, and 2. So I just took the 2, 2, 0, 1, and I doubled that to 4, 4, 0, 2. So now in my graph here below, this is my original function done faintly, and that's just for reference. So what happens is my y values get doubled, so you can just see how this works out. There are my points. I'll try to draw them, put them smoothly. This one's a bit of a tough one to get. Oh, I did pretty good. Okay, and it ends right there, and this ends right there. And here are my points. So you can see, compared to the original function, exactly what happens when I get my y is equal to 2 times the f of x. Alright, let's do this one. Let's use green for this. Not too surprising, I don't think, that what we're going to do here is we're going to multiply the y values by 1/2, by this half right there. So if we have x, and then we have y is equal to 1/2 f of x, -3, -1, 1, and 2, and then we had 2, 2, 0, 1, so I get 1, 1, 0, 1/2. Again, this is my original function done for reference, so if I'm multiplying this times 1/2, kind of goes like that. And you can see very clearly then this would be a, in blue, this would be a stretch. Oh, I want blue there. Stretch. And this one here would be a compression. But both of them are of the vertical variety. So this would be a vertical stretch, and this one would be a vertical compression. Okay, are there any invariant points? Sure. Here's an invariant point right there, and here we have an invariant point right there. And you'll notice something about that. The invariant points happen on the x-axis, so wherever y is equal to 0. Because 0 multiplied times 2, if we're multiplying the y values times 2, when I multiply a 0 times 2, I still get a 0. And here, if I multiply the y values by a half, a 0 times a half is still a half. So that's why that point stays the same. Here, I'll point out here, the generic way of looking at this, instead of a 2 there and a half, before we're using h and k to talk about translations, here for the vertical stretch or the vertical compression, my basic pattern is to talk about y is equal to a multiplied by the f of x. So in this first example, I could say a is equal to 2. In this example over here, a is equal to a half. Okay, so if we've learned something, that if a is greater than 1, then we're going to get a stretch. In fact, we're going to get a vertical stretch. If a is less than 1, then we get a vertical compression. But we have to be a little bit careful in our definition here, because looking at our previous page, okay, so in this example, you could say that a is equal to -1, right? And it's not if we had a value that was -2 or something, that would be a reflection and a stretch. So so I'm just going to be a little bit cautious here, and I'm going to say, instead of saying a is greater than 1, I'll talk about the absolute value of a, and the absolute value of a less than 1. So we'll do more about that right now, but for right now, let's limit our discussion to talking about a when it's positive, and then later on, if a is negative, we can still use this same rule. So whatever number out in front, that's going to be multiplying the y values, and if you're multiplying by something greater than 1, you're going to be causing a vertical stretch. If you're multiplying by something then smaller than 1, then clearly the y values are getting smaller, and then you get that vertical compression. You know what? I'll pause and make this another video for your next one.